So here is another question on simple harmonic motion. It is given that a particle executes simple harmonic motion of period 8 seconds, time period 8 seconds. After what time of its passing through the mean position will the energy be half kinetic and half potential? Okay, so basically what it is saying that the kinetic energy and potential energy, they are equal because the total energy is always constant. Total energy, that is the sum of kinetic and potential energy, it is always constant. So here both EK and EP, they should be equal, half kinetic and half potential, and both are equal. Only then it will be which is equal to half of the total energy. This, okay, this is the thing. So here first we have to write the standard SHM equation, that is y is equal to a sine omega t. Okay, it is given that the time period is equal to 8 seconds, so angular frequency 2 pi by time period, which is equal to 2 pi by 8, which is equal to pi by 4. Okay, this. Then we know that the kinetic energy expression EK is equal to 1/2 k a square minus y square, where k is the force constant. Okay, k is the force constant, which is given by k is equal to m omega square, where m is the mass, omega is the angular frequency. The values are not given, but we don't need them. We will calculate still without these values. And the potential energy is equal to 1/2 k y square. So both of them are related to the instantaneous position y, the displacement of the SHM motion. So here, according to the question, half kinetic, half potential, it means both of them are equal, ET by total energy by 2, half of the total energy. So here EK is equal to EP. Okay, EK is equal to EP, kinetic energy is equal to potential energy, that implies 1/2 k a square minus y square is equal to 1/2 k y square. So 1/2 gets cancelled, k gets cancelled, that implies a square minus y square is equal to y square. That implies a square is equal to 2y square. That implies y square is equal to a square by 2. That implies y is equal to a by root 2. So at y is equal to a by root 2, at this position, kinetic energy and potential, they are equal, half of the total energy. Okay, an alternative way in which we have got the same result is using this relationship. Okay, this one. So according to this, at that particular time, both the kinetic energy and potential energy, they are half of the total energy. Okay, so that means 1/2 k y square, which is the potential energy, is equal to 1/2 of the total energy, which is equal to 1/2 into 1/2 k a square, because the total energy is 1/2 k a square. So here we will cancel 1/2 k, so we are left with y square is equal to a square by 2. That implies y is equal to a by root 2, and it is on either sides. Okay, plus minus will be appropriate, that is on both sides of the equilibrium position at a by root 2 and minus a by root 2 we will achieve the same thing. But here it has been asked after crossing the mean position, equilibrium position, where? So magnitude wise it is a by root 2. So this way also we will get the same result. Now we have to determine the time. Okay, so for that we have to replace this position y in the displacement equation. Y is equal to a sine omega t. That implies the specific position a by root 2 is equal to standard displacement equation of SHM, a sine omega t. That implies sine omega t is equal to 1 by root 2. Now we have to find a sine function whose value is equal to 1 by root 2, which is sine 45 degree, or in terms of radian it is sine pi by 4. That implies omega t is equal to pi by 4. We have calculated the value of omega here. Okay, omega pi by 4. Omega is equal to pi by 4. We have calculated it here. So we'll substitute that value here. That implies pi by 4 into t is equal to pi by 4. That implies t is equal to 1 second. T is equal to 1 second. So the at time t equals to 1 second and position y is equal to a by root 2, the energy is half kinetic and half potential. Okay, exactly. So here is another question on energy of an object undergoing simple harmonic motion. So it is given that at a time when the displacement is 1/3 of its amplitude for an object undergoing SHM, what fraction of the total energy will be kinetic energy and what fraction will be potential energy? Okay, so here the standard SHM equation format, that is equal to y is equal to a sine omega t. Y is instantaneous position or displacement from the equilibrium position, and a is the amplitude, and omega is the angular frequency, and t is the particular time. Initial phase angle information is not given, so phi is equal to 0. Now according to the question, at a particular time t, the displacement, the instantaneous position y is 1/3 of the amplitude, the maximum displacement. Y is equal to a by 3. So here at this particular time instant, if we calculate the potential energy first, okay, we know potential energy is equal to 1/2 k y square. So that is equal to 1/2 k, y is equal to a by 3 whole square. So that is equal to 1 by 2 k a square by 9. Now we know that the total energy in SHM, that is equal to 1 by 2 k a square, that is the total energy. So here we can write it as 1 by 9 into 1 by 2 k a square, which is equal to 1 by 9 of ET, the total energy. 1 by 9, 1/9 of the total energy. Then kinetic energy, that is equal to 1/2 k y square, sorry, 1 half k a square minus y square. Okay, 1 half k a square minus y square, a square minus y square, which is equal to a square minus a by 3 whole square, that is equal to 1 by 2 into k into a square minus a square by 9, that is equal to 1 by 2 k 8a square by 9. Okay, so we can write it as the kinetic energy Ek is equal to 8 by 9 of 1 by 2 k a square, which is equal to 8 by 9 multiplied with Et, the total energy Et. So the potential energy here is equal to 1 by 9 times of the total energy, and the kinetic energy is equal to 8 by 9 times of Et. So if we add them together, we'll get the total energy Et. 9 by 9, that is equal to 1. So at a particular position or displacement where the instantaneous position is 1 by 3 times of the amplitude, the fraction of total energy, which is potential energy, is 1 by 9 of the total energy, and kinetic energy is 8 by 9 of total energy. Okay,